Hello, guys. Welcome to another video lecture, supergenius99.com. We're going to go with some C# basics. There will be no coding in this slideshow, but there will be some coding in the next slideshow. So let's get into some C# basics. All right, so what we'll be covering today is OOP, object-oriented programming. Syntax, types, numeric types, Boolean types, and operators, strings, and characters. OOP. So what is OOP? So formal definition of OOP is object-oriented programming. OOP is a computer programming model that organizes software design around data or objects rather than functions or logic. So before there was OOP, there was procedural programming. Basically just meant that any function could access any variable. So it was kind of willy-nilly, and you just kind of had to trust that everybody was going to behave themselves in the when they wrote code, and that a method or a function would not operate on a variable unless it was supposed to. So when we come to object-oriented programming, think of it this way. Okay, think of a vehicle, and you don't have to know the inner workings of a vehicle. So before their vehicle, obviously there was horse and buggy, and you could probably look at your horse and carriage and kind of figure out how it works, right? It's not too hard. Got a horse, you got a carriage. The carriage has wheels. When you want the horse to move, you crack your whip, giddy up, horse starts moving, the wheels start turning because the wheels on the bus go round and round. But when you have a vehicle, it's got some more layers of complexity, right? And there's probably a lot of people who drive who don't understand every part of that car. Okay, so you crank your key, engine starts running, or nowadays you push a button. See, I'm letting you know I'm well past 30 here. I'm well past 30. Yeah. So in the olden days before modern cars, you have to, put in a key, crank the engine. So you can still watch those on movies that's not using the modern day cars. You see them put in a key and crank the engine, and then you would have to shift the car into reverse or drive depending on where you start. Okay, how your car is parked. But then it's like rather than legs of a horse moving, you got the pistons moving and things in the engine moving around, and that causes the wheels to move, and so forth and such. And of course, that's an overly simplified version of all the things that happen. But point in case is you don't have to know everything that's going on because the car, right, is operating like an object. Okay, all you have to do is interact with the car with the interface, right, the user interface designed by the car company. And so the same thing is in procedural programming, preceded programming that preceded object-oriented programming. You would have to work on each individual. You have to know the nitty-gritty in order to write the program. With object-oriented programming, you don't have to know that. Okay, it's very simple, and it makes it cleaner, and then obviously helps you write code faster. Syntax. So what is syntax? Right, the rules of conversation. Okay, so syntax relies on the rules that define the structure of the language. Okay, so similar to natural languages or spoken languages, programming language has got rules and got mechanics, right? So like in the English language, if I wanted to talk about a blue pants, I would say blue pants, the blue pants. But in Spanish, I would say pantalones azul, right? So different different languages might have different rules. Same thing. Different programming languages will have different syntax, and the syntax, unlike in a spoken language, I might say something incorrectly. I might leave a word out. Like I might say tomorrow I have to go to work, and rather than saying that, I might just say tomorrow I have work, or rather than I'm going to work, I'm going work. And even in languages, you might have, variations, right? The street language, right, or the professional language spoken, in the corporate world versus the language spoken by people on the streets to sound cool. So you got syntax. There's many different syntaxes, but in a spoken language, if you forget something or leave something out, or you don't pronounce a word fully, people can kind of figure out what you're saying. In programming, it doesn't work like that. The computer is ignorant. The computer is stupid. It only knows what you say. So you can't come around and say, "Well, you knew what I mean," right? So if you say something wrong to a child or to a coworker, you can come back and say, "Well, you knew what I mean." Well, the computer doesn't know what you mean; it only knows what you say. So you can't go complain to the computer or the compiler or the programming language. Oh, you know what I meant. No, it doesn't work that way. It's a syntax that has rules. So types. All right. So every programming language has different types. For example, there might be there's user defined types and built-in types. And so you can think of a type like this. Okay. Maybe there's a young man. You can put him any grade, junior high, high school, college. And he sees a lady in his class, looks like she's a hard worker, she's smart, caught his eye, she's pretty, you know. Thinks to himself, hey, let me ask her out for Saturday night. Maybe we'll go rollerblade or bowling or something fun. And he asked her out after class, and she says, "You know what? Seemed like a really good guy, but you're not my type." What does she mean? When somebody says someone else isn't their type, they mean that we probably won't work well together. We won't communicate well together. How I do things and how you do things are differently, and maybe even how I see things and how you see things are differently. Are your definition of something and my definition of something is different to the point where we won't work well together, or we won't operate together, or we won't get along together. Okay. So same thing is with the different types, the built-in types and the user-defined types. When there are two different types, and you'll see the different types on the next slide. What it's saying is those two different types may not work well together out of the box. You might have to do something so that one can understand the other in a smooth way, in a clear way. And so there's some compilers where there's some languages where if you do try to get two different types in the same statement without doing some type of translation, okay, it'll try to translate it for you, and it may or may not be what you want. And then some programming language, they won't do that. It'll just send you a little error message, won't even run the code. These two objects are of different type. Uh, you need to do some conversion. We're not going to do the conversion for you, which is a good thing because you don't want your programming language doing the conversion for you, because then you got your programming language trying to figure out, like I said earlier, what you mean. And a smart programming language is not going to try to guess what you mean. You need to do things correctly and properly. So programming it's very correct, it's very proper. It's not sort of, kind of, maybe, almost. You have to do things correctly. So there's built-in types, which means it's already provided to you by the programming language. You got user-defined types. So let's look at one type of built-in type, numeric types. You got integer, float, double, decimal. Okay. Now, do understand not everything that is a number is necessarily a numeric type. For example, social security number, credit card number, license plate number. Although they are numbers, they are not numerical types because numerical types are designed to be operated on or used in a mathematical operation. And so maybe credit cards, you might store that as a number because you might use some type of mathematical operation in order to verify it, to verify that it's an active card, or you might just send the number to a certain process that will do it for you. But everything else, integer, float, double, decimal, you can see their types. You can see how much storage they use on your computer in memory. And the reason why you have different storage. So float, double, decimal. So in math class, what did you have? You had integers, right? And then you had fractions, and then you had decimals, right? And then you had imaginary numbers. Okay. So we don't do a whole lot of imaginary numbers in programming. In fact, I don't think we do any at all. But notice how we don't have fractions. Okay. So you don't have fraction. So if you wanted to create a fraction type, okay, you would have to design that on your own. So a fraction type is not defined out of the box. You would have to build that. So inside every programming language, they give you the integers, which is, remember, it's the whole numbers. It's all the counting numbers and zero and their opposite. So negative 1, 2, 3, 4, 0, 1, 2, 3, 4, all the negative numbers, but just the integers, right? The whole numbers. And then you have float, double, and decimal. So all those in mathematical terms are decimals. You just have different precision types. So one is longer than another because when you're doing those mathematical equations, you may need certain precisions, right? So that your results will be as accurate as possible. Boolean types. Okay, what's a Boolean type? So Boolean is true or false, right? In math, I think when you're doing math, you use 0, 1. In programming, you use true or false. Okay. So if you're taking certain math classes, most likely not the freshman, excuse me, probably the junior classes, you'll come across truth table. I think abstract algebra might do it, and there's some other algebra classes that do the same, and assignment operator. So yeah, and some other classes do truth tables, but it's true or false. So Boolean sees everything as black and white, true and false, right? Yes or no. That's all it sees. Okay. And it's usually used in what would you call it? In an if statement. So most likely you got multiple paths. And if this is true, I'm going to do one thing. And if it's not true, I'm going to do something else. Okay. That's usually how it works. Or if it's false, I'm going to do something else. All right. Assignment operator is the equal sign. So in math, equals meant a statement, right? And in math, you might have x plus y equals 10, and then 2x plus 3y equals, who knows, 12, and you figured out where those two lines intersect. That's not what we're going to be doing in this class. So this right here just assigns and says x equals 5, and you have to put that int in front of it to say what type it is. So the value of 5 is assigned to a variable named x, whose type is integer. Okay. And so only integers can be assigned to x. And so if you try to assign a decimal, what some programming languages do is they'll either say, nope, sorry, we're not doing this. We don't take decimals. Or it might just round the decimal down to the nearest number. So if you were to put 2.7, sorry, it wouldn't do it would do a floor round, not a mathematical statistic round. So do a floor round, which basically means it truncates. So rather than 2.7, it would put in 2. So do note that, because some programming languages, if you give it a decimal, it will not round up. It'll truncate, or it'll just complain. Okay. So do understand what truncate does. Truth operators, the or and the and. So the or is the double slash standing straight up and down, and the and is the double ampersand. So the and works like this. Both the left side and the right side have to be true in order for a certain action to take place. So I might say, if it's raining and cold, I'm going to stay home. So Saturday rolls around, and I'll check out the news. The forecast says it's raining and it's cold. So it says it's raining and let's call cold, and it's 30 degrees. Will I stay inside? Yes. But what if it's raining and it's 100 degrees? Will I stay inside? No, because I said it has to be raining and cold. It's raining and hot, so I'm going outside. Or let's say it's 30 degrees, but it's sunny outside. Will I go outside? Yes, because I said I'm only going to stay inside if it's raining and cold. So and says both sides have to be true in order for the next action to take place, or else it's false. Okay. But with or says either one can be true. I don't need both of them to be true. I just need one of them to be true. So if I say if it's raining or cold, I'm going to stay inside. So that means if it's raining outside, I'm going to stay inside. If it's 30 degrees outside, I'm going to stay inside. So the only way I'm going to go outside if it's not raining and it's not cold. So it has to be both not raining and not cold, and then I'll go outside. That's the way Booleans work. Strings and characters. So a string is a set of, let's go with characters. A character is just one letter, number, or special character. Okay. It can only be one. Okay. Only one, not 5, not 10, not 25, one. If you try to put anything other than just one character, the compiler will complain. It should start with char initial, not string initial. So this right here is incorrect, and I'll fix it when we code in the next video. So it should be char initial J. Okay. And then have string name John. So the the string is like multiple characters back to back. And inside those double quotes, you can put a space. Okay. You can put a letter, you can put a number, you can put a special character. Same thing with the string. I mean, a character. A character can be char initial and then just a space. So even an empty space and only one empty space you can put as a char. But a string can be a string of empty spaces. You can have 4 empty spaces. You can have 5 empty spaces. You can have 20 empty spaces. So a character can be a whole lot of things. But like I was saying earlier, with those credit cards and social security and driver's license plate numbers, those are really strings. They're not numbers because you don't do any mathematical equations on them. You know, you don't add, you don't subtract, you don't multiply, you don't divide them. So for maybe the credit cards, you might do some mathematical operations on them. But the other ones, you don't have it because they're not numbers, they're identifiers. Okay. So sometimes a number is used as an identifier, and that might be misleading as to its purpose. Okay. And so another type of string you might have is the GUID, right? A unique ID, which is numbers, letters, and characters that look like gibberish. Sometimes that's also can be used for a good password, which is a string. It would just be string, password, and then the gibberish. And of course, the reason why you want to have, if you are making email addresses or, passwords to websites, you want to use gibberish so that a person cannot use a dictionary. A person cannot use a dictionary and try to hack your password. Okay. So I think that's going to be it for today or for right now. We're going to do some coding next time. Super Genius 99. Thank you for watching.